Good morning, most valued listeners, and welcome to today's class. We strongly believe that you all had a wonderful nights. Welcome today to our class as we intend to discuss some strong secrets in evaluating problems that concern logarithms and indices. Of course, no effort is enough in teaching the links and connections between logarithms of numbers and indices to our students or audience. Since these two major concepts in mathematics form the basics of so many mathematics and statistics problems. So today we have come again with few examples to solve with you with the intention of explain all the more these connections and links between logarithms of numbers and indices, which of course will go a long way to helping you navigate your ways in so many challenges in mathematics and statistics. Therefore, stay put as we call up the questions on the board and then solve with you in the way you will understand and appreciate. So we are beginning from number one, and I write. Number one says, number one says, number one. It says, given that log y base 10 equals what? 2. And log 2x base 10 equals what? 1. Evaluate log root y base 10 all over 3x. That's what the first question says. It says, given that log y base 10 equals 2 and log 2x base 10 equals 1, we should use this information to evaluate this problem. So our going to get this problem correctly depends on our doing necessary transformations in these logs. And the necessary transformations needed for us to do in log y base 10 being equals to 2 and log 2x base 10 being equals to 1 is to transform these from logarithms into their indices equivalents. And I do remember for you, by a way of solution, I'll write solution. By a way of solution. Remember that when you are given a log of a number in this form, you are given what? Log of what? N base what? A. And you are asked to transform this log of base n, log of n of base A to indices. You simply can say, let this be equals what? X. Then this is the base, which is A. It now becomes that base raised to power of this what? X is equal to this n, which is the number. So this thing becomes what? A raised to power this what? X is equal to this capital N. This has ceased from being a logarithm. It has become an indices. So what we are going to do in this is to use this idea to transform these logarithms now into indices. And for that note, I come here. I divide this line this way. The number I have here is, I have what? Log of what? Y in base what? 10 equals what? 2. I am looking at this y as if to say it were n. I'm looking at this 10 as if to say it were a. I'm looking at this 2 as if to say it were what? X. So I'm going to use the same method to transform this number into this log into indices. The base here was A. Look at where the A is. I equated it to x. The x has become the power of what? Of A. Applying that same way to this log of number, what I have here is 10. What I have here is 2. So I have that my 10 raised to power 2 is equals to what? 1. So I have transformed this number now into transform this logarithm into indices. I am done with this one. I come over this place. This one says that log of what? 2 what? X in base 10 equals what? 1. Here I'll be looking at 10 as if to say it were A, looking at 2x as if to say it were n, and looking at 1 as if to say it were this x. And I move. So this thing implies, here is my 10, I'll write 10. Raised to power what? 1 is given as what? 2x. My interest is to obtain x and not to obtain 2x. Therefore, I'm going to use the coefficient of x to divide both sides for me to arrive at the value of what? Of x. And doing so, what I now have is becomes what? Remember, anything raised to power 1 is that 10. So this is the same thing as what? 2 what? X is equals what? 10. I will say all over 2, all over 2. 2 will cancel these 2. So this implies what I have here is what? X. 2 into itself is 1. 2 into 5 into 10 is what? 5. So my x is 5. Having got the value to be 5, what do? I now say therefore. Now I know the value of x. Now I know the value of y. I will return back to the problem I was asked to evaluate. I was asked to evaluate log of root y. I am happy now I know the value of what? Of y. All over 3x. I am happy now I know the value of what? Of x. So this question has reduced to a mere substitution. So I will now say therefore log of what? Root of y in base 10 all over 3 what? X equals. Here is now log of root. I won't write y again because y has become 10 raised to power 2. And 10 raised to power 2, of course, is 100. So it has become what? Root 100 all over. Here is my 3 multiplied by. My x is what? 5, which means multiplied by what? 5. Of course, you know that root 100, which is square root of 100, is 10. So what this thing becomes is, this equals log. This is base 10. Root 100 is what? 10. Base of this what? 10 all over. 3 times 5 is what? 15. Of course, you know that log of a number to its own base is what? Is 1. Therefore, this log 10 base 10 is what? Is 1. So the entire numerator has become 1. So this equals 1 all over. What I have as denominator is what? Is 15. So the answer is 1 over 15. As a recap quickly, I was asked, given that log y base 10 is 2 and log 2x base 10 is what? Is 1. Evaluate log of root y base 10 all over x. You cannot evaluate this problem without you knowing the value of y and x. And where you can obtain your value of y and x is from this expression that is given to you this way. To obtain the value of y and x from these logarithms means I am going to transform these logarithms into indices. How do I transform logarithms into indices? I come back here. It is known in logarithm that whenever you are given log of n base a and you are asked to convert it now to indices, you equate it to what? To a variable. Be it x, be it y, be it z, be it w, be it t. I have chosen because conventionally people always go for what? For x. So I have equated it to what? To what? X. To transform this thing now into indices is the base of the log raised to power this number which we equated it, this letter, which is a raised to power x is equals to what? N. This now is in form of what? Indices. So I am going to apply this method now in this. What I have there is log of y base 10 is equals to. Treating this as I did to this one, it has become 10 raised to power 2 is equals what? Y. This is the value of y now. I am glad I've arrived at the value of y. I come over here. This is log of 2x base 10 is equals 1. My interest is to go to get what? X. But I first of all need to transform this into indices. So it has become 10 raised to power 1, which is this, equals what? 2x. Which is that. My interest is to get the value of x and not 2x. What do? I now come over here. Trying to divide both sides with the square root of what? X. Sorry, with the coefficient of x, which is what? 2. Then I have 2 will cancel 2. I am left with x, which is x. These 2 will cancel this what? 10, which will give me what? 5. I am glad I've got a value of what? Of 5. So I quickly come over here now. When I come over here, what do now? I will now say therefore, log of root y base 10 all over 3x. Anywhere I see y, I will now put in what? 10 raised to power 2. And anywhere I see x, I'll put what? 5, because these are their values. So I quickly say log of, instead of putting y here, I'll put 10 raised to power 2, which is 100, all over 3x. Then in place of what? X, I'll put what? 5. And then what I have is, of course, you know that square root of 100 is what? Is 10. So I now have 10 base 10 all over. 3 times 3 is what? 15. Log of a number to its own base is what? Is 1. So I will now be able to have what? 1 over 15. And with this, you must have provided an answer to that particular problem. I really want to believe that you did not have a challenge in this problem which we have just trashed with you. We are looking forward for your audience as we continue to make effort on daily basis to continue to bring mathematics and statistics to your doorsteps in a very most simplified way. Thank you and remain blessed.